Hey guys, welcome back to my channel. Today we're going to talk about the VxLAN protocol. VxLAN is nothing but virtual extensible LAN. It helps you create a virtual network on top of an existing network. It is also called an overlay protocol. Okay, the existing network or the infrastructure which it runs on is basically called underlay. Okay, now let me show you an example over here. Okay, what I mean by underlay and overlay. Okay, now let's say I have a router. I have another router over here, I have another router over here, I have another router over here, another router over here, another router over here, and then I have a switch over here, and this is connected to a host. Okay, similarly I have a switch over here which is connected to a host. Okay, let's call this host 1, let's call this host 2, this is switch 2, switch 1. Okay, and let's call this to be routers. Okay, R1 to R2, and the routers in the middle could be named anything. Okay, now R1, R2, let's call this R3, R4, R5. These are basically physical networks which are running on the internet. Okay, these are all the physical networks which are running on the internet. Okay, now if a packet has to go from R1 to R2, it has to either go through R3 or R4 or R5 and then to go to R2. Okay, so this is something, an IP lookup has to happen or a label lookup has to happen, and the packet will be forwarded from R1 to R2, right? So this is basically called underlay network. Okay, this is the infrastructure of the network on top of which an overlay runs. Now what is an overlay? Overlay is nothing but, imagine it as a tunnel. Okay, so VxLAN is also called as a tunneling protocol. Okay, that allows you to connect two layer 2 segments together over a layer 3 network. Now think of this as there is a tunnel from here to here. Okay, this is my VxLAN tunnel. Okay, now what happens is, let's say this is 10.0, let's say 10.1.1.1. okay, and this is 10.1.1.2. okay, now I want to communicate from 10.1.1 to 10.1.1.2. okay, now if you notice, both host 1 and host 2 are part of the same network. Okay, they're part of the same network, they're part of the same 10.1.1.0/24 network. Okay, now but they are separated by multiple routers in between. Make sense? Now can I, so what I have done is, using a VxLAN, I have expanded the layer 2 segment, or I have expanded my LAN segment. Okay, I'm able to ping 10.1.1.2 from 10.1.1.1, which is part of the same network but in a different location altogether. So what have I done? I have expanded my LAN, correct? I have extended my LAN basically. Okay, so it basically means, let's see, you are in a room. Okay, you're trying to communicate. You are on your own private network, private LAN. Okay, but let's say I have, in some different country, I have another room which also supposed to be part of my LAN. Okay, and I want it to be uh, able to communicate with it without going out of the network. Okay, so what do I do? Is that possible? Essentially you have to go over the internet, but what I'll do is I'll encapsulate that packet. Okay, I'll encapsulate that packet with a VxLAN header, and I'll put a inside IP header and inside MAC address so that that packet can reach host 2. Meaning, let's say if the packet has to go from R1 to R2, it has to do traditional routing. Okay, so I'll have a layer 2 header, right? I have a layer 3 header. Okay, this layer 3 header will have the source IP, it will have dest IP. Okay, but what will the source IP be? Source IP will be R1, dest IP will be the IP of R2. Make sense? Okay, and layer 2 source MAC would be the MAC address of R1, okay, and sorry, host 1, and the destination MAC would be the MAC address of R1, okay. Now what happens is on R1, okay, I have something called as VTEP, okay. VTEP is nothing but VxLAN tunnel endpoint, okay. VTEP 1, and at R2 I have VTEP 2, VxLAN tunnel endpoint 2. So what I'll do is, so host 1 wants to send a packet, okay. Now let's say what will host 1 do. Host 1 will have a source IP of 10111 and destination IP of 10112, correct? Okay, so host 1 will give me a L3 header. Host 1 will also give me a L2 header, okay. Now this L2 and L3 header, okay, along with a frame, right, along with the data, whatever L5 application layer data is given to me, okay. Now this packet will come to R1, okay. Now this packet R1 will see that it is a VTEP, okay, it's a virtual tunnel endpoint, okay. That means this packet needs to be encapsulated inside another packet, okay. Now this packet will be encapsulated inside a UDP header, okay. So layer 4 is what? Layer 4 is UDP header, and inside this I'll have my VxLAN header. I'll tell you what all VxLAN header will have, and I'll have the inner frame, okay, inner Ethernet frame, which is inner L2 and inner L3. Make sense? So what I have done is I have encapsulated this part inside a UDP header. Okay, make sense? So so what will be my L3 source IP? That will be the VTEP, okay, virtual tunnel endpoint source IP, VTEP 1. Destination IP will be that of the VTEP 2, which is my virtual tunnel endpoint 2. So basically I'm creating a tunnel from these two endpoints, from R1 to R2, okay. I've created the tunnel. Now the VxLAN header will basically have a VNI, which is nothing but VxLAN network identifier. It is a 24-bit long, so I can have about 16 million VxLAN segments, okay. Now if you remember, we have also discussed about VLANs. VLANs are also basically used to segment the private LAN, right? So you can have segmentation of the private LAN as well using the VLANs, but VLANs are only 12 bits, so they allow only about 4000 VLANs. So VxLAN helps you to scale up rapidly, okay. And this VxLAN generally came into existence when we started having virtualization servers. We have virtualization techniques now. Instead of, we are just using one particular hardware and we are spawning multiple VMs, and these VMs are able to act as servers for different purposes. Now different tenants, now there's a concept called multi-tenancy, where on one server I can have traffic of multiple tenants coming in, but this traffic has to be isolated from each other. They cannot mix up, right? Because they belong to different tenants. So we have to provide secure network to them. You have to provide reliable network to them. And this is where VxLAN comes in, where VxLAN is able to encapsulate that traffic. It's able to segment that traffic, okay, so that it does not get mixed up between different tenants. And it also helps you to have lot more customers, because VLANs can only give you 4000 VLANs, but VxLAN can go up to about 16 million VxLANs, okay. So one of the field of the VxLAN header is VNI. VNI is the virtual VxLAN network identifier. It's like a VLAN ID only, like VLAN ID has 124094, like that VNI will also be like a number, 5021 or something like that, 5022, something like that. So let's call this VNI 5021, okay. I can have one more tunnel which is going from maybe here to here, okay. So at a VTEP I can have multiple VNIs, okay. So let me just erase this. So now you understood, right? So I have a outer L2 header, outer L3 header. I have a UDP header. Inside the UDP header there is a VxLAN encapsulation done, which has a VxLAN header and the inner L2 and L3, okay. So what happens is the packet goes from R1 to R2. So At R2, what happens? It strips the outer L2 and outer L3. Okay, it sees that it has an inner L2 and inner L3, and inner L3 destination would be what? 10.1.1.2, right? So this would be the inner destination IP. So it knows that the packet has to go to host 2, correct? And the packet will be forwarded to the respective inner destination IP, and based on the inner MAC address, it will forward the packet to host 2. So now what have we done? We are able to communicate from host 1 to host 2 over internet. Okay, but if you see, right, these two are part of the same network. Okay, so I'm able to create a secure channel for these two to communicate over the internet, where the internet does not know anything about what is happening inside. The packet is encapsulated, so they don't know anything about where this packet is supposed to eventually go to. Okay, so it helps you provide secure, reliable networks. Okay, it helps you to segment these networks. Okay, about 16 million segments you can have. Okay, now also so it also increases the broadcast domains across the internet. Okay, now you don't have to have just like one particular, you don't have to be in a same, like I told you, like a LAN is where where say you have a room and there are like 8 computers and all of them are using your network, so it's limited by geographical area. But with VxLAN now we can increase that geographical area to like any distance. Okay, because of VxLAN you're able to send a packet from over the internet, but it still is part of the same L2 layer, L2 structure. Okay, so this is what VxLAN does. And this is most commonly used during virtualization techniques. Okay, so let's say I have a server. Okay, now this server can spawn up like a lot of VMs. Okay, now this VM can be of company A, this VM can be of company B, this VM can be of company C, this VM can be of company D. Now same 4 companies might be located somewhere else geographically, right? They may have a different branch somewhere else, A, B, C, D, right? And they want to communicate. A's traffic has to go to A only, B's traffic has to go to B only, C traffic has to go to C only. It's kind of like imagine it as a private network, virtual private network, VPNs, right? So VxLAN helps you to be able to communicate over internet, and that too in the same network. Okay, so this is a very important protocol, which is, it's a tunneling protocol which is now generally used in virtualization techniques. We will talk in detail about virtualization, about different types of virtualization, what all is there, like how resources are allocated and everything. During that time also we'll talk about VxLAN. I just wanted to cover this as a part of the networking topic, so you're able to understand, like there is something called as VxLAN also, which overcomes the limitations of VLANs. Okay, so I hope this made sense. I'll share a link with you guys, just a informational link. Just go through it. Important thing is to know about the VxLAN header, know about the VTEPs, how the VTEPs encapsulates the packet over here at R1 and how it decapsulates the packet at R2, and then it will use the inner IP headers and inner MAC addresses to forward the traffic to the respective host. Okay, I hope this made sense. Please let me know if you guys have any questions. Please like, share and subscribe. Thank you.